Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Basic Graphs of Trigonometric Functions, Range of the cosecant of x. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. Inbox me at memedicine@gmail.com to order this complete cram session. Be sure to spread the word to your friends and classmates who also need to cram. Let's cram range of cosecant of x. Basic graphs of trigonometric functions. Range of the cosecant of x. And before we actually delve into the concept, I want you to recall a few things, specifically what the cosecant of some specific angle x is. And here in our pre-example, we're going to allow the Greek letter theta, lowercase theta, to represent the angle instead of x because we're going to use x as our x variable, so we don't want to double up on variables, okay? All right, so here you can clearly see that we have our x, y Cartesian coordinate plane, origin in the middle, and the vertex of this angle theta is at the origin. The initial side ray is on the positive x-axis, terminating at its x-coordinate, and the terminal side ray ends in quadrant 1. Thus, this is an acute angle, all right, and this ray terminates at the y-coordinate, forming the hypotenuse, or the longest side of the triangle, R. And the x-coordinates can be positive if you're in quadrants 1 and 4, and negative if you're in quadrants 2 and 3, okay? Whereas the y-coordinate can be positive if you're in quadrants 1 and 2, and negative if you're in quadrants 3 and 4. Okay, so that should orient your mind a little bit. And quadrants can have signs, but the magnitude, a magnitude is a measurement, usually resulting from the distance formula, which is squared. So this magnitude is always going to be positive. Any measure of magnitude or distance is going to be positive. Okay? Alrighty then. Okay, those things are checked off. Oh yeah, this is an acute angle. Acute angle occurs between the extent of the quadrantal angles 0 degrees and 90 degrees, all right? This acute angle can also be considered a reference angle. Reference meaning whenever you plug or whenever you're trying to solve for some trigonometric value or inverse trigonometric value in your graphing calculator or scientific calculator, it's always going to give you the value of an acute angle, okay? At least most of the models do. Maybe some of the newer models know how to incorporate quadrants 2, 3, and 4 as well. And and let's say you were to have this reference angle, which could be something like 40 degrees. Let's say you were to do a vertical flip about the y-axis and you ended up in quadrant 2. You would have something that looks like this. Okay, but we know we're not interested in the reference angle. What you would actually be interested in is this thing. This angle right here. So when you're in quadrant 2, you would have to basically subtract the reference angle from the extent of this quadrantal angle, which is 180 degrees, and your angle of interest here would be 140 degrees, okay? Or let's say you did a diagonal flip about the origin, and you landed over here in quadrant 3 land. Okay, excuse my janky scribbles. What you would be interested in is this angle and not our flipped theta, okay? And that angle is basically going to be the extent of quadrant 2 plus our reference angle. So the extent of quadrant 2 is 180 degrees plus our reference angle. So 180 plus 40 is 220 degrees. Okay, I think you're getting more clear on this. And let's say you were to do a horizontal flip about the x-axis and your reference angle winded up over here in quadrant 4, well, you wouldn't be interested in theta, or actually, yeah, theta is over here. Not gonna erase that. What you would be interested is this big guy, and that's going to be the extent of the quadrantal angle, which in this case is going to be 360 minus theta. So 360 minus theta would be 320 degrees, okay? All right, that was a long aside. Any other points that we need to go? Oh yeah, we need to cover what the cosecant of theta is. Well, the cosecant of theta is going to be the longest side, the hypotenuse, which is always positive, divided by the y-coordinate. Or let's say you were not in a Cartesian coordinate system, it would be the side opposite the angle of interest. So the longest side divided by the side opposite the angle of interest. Within our Cartesian coordinate system, it's going to be the terminal side ray, or divided by your y-coordinate, okay? And notice that the cosecant of theta is the cofunction to the sine of theta, and the sine of theta is just basically your y-coordinates, or your opposite side, divided by the hypotenuse, the longest side, or the terminal side ray, okay? So if you multiply cosecant of theta by the sine of that particular angle theta, you're going to end up with 1. So that was just to orient you. Let's get on with the actual concept. So what is the range of the function y equals the cosecant of x? And when I say range, I'm talking about the set of all possible values for the dependent variable. The dependent variable here is going to be our y values, or y coordinates, the complete set of y coordinates. And they depend on the independent variables, or your x values, okay? And if you watched or ordered this complete cram session, you would have found out what the domain of the function y equals cosecant x is, and the domain is the set of all possible x values for a particular function, or independent variables, usually the ones occurring along the horizontal axis. So press pause if you need to, and I'll give you a moment to figure out what the range of the function y equals cosecant of x is. Be sure to draw a graph properly labeled to support your reasoning. This may take a while, so press pause. Okay, so hopefully by now you are able to arrive at an answer, but if not, that's completely fine. Here goes our example graph of y equals the cosecant of x. And the range, well, first of all, we know from our other cram session that the domain, the set of all independent variables, x values, is going to be all real numbers except whole number multiples of pi, or whole number multiples of 90 degrees. And so, based on visual inspection, the range is obviously when y is, or the dependent variable is less than or equivalent to -1, okay, or greater than or equivalent to 1. All right, so that is our answer for the range, the set of all dependent variables. And you don't need mathematics to solve this or to reason this out. You just basically do a visual inspection after you draw your graph. You would probably need your graphing calculator to assist you with this. And a lot of graphing calculators don't have the cosecant function. So what you're probably going to have to do is put in 1 over the sine of x, which is the reciprocal of the cosecant of x, okay? That's why I mentioned that to you before with the pre-example. Oh, yeah, and I did mention that the domain, which we're not interested in here, we're interested in the range, but the domain is the set of all real numbers. And when I say real numbers, I mean any counting. Real numbers include integers, rational numbers, and irrational numbers. Integers being counting numbers that occur in the number line, like 0, -1, and 2, like here, the origin, and 2 over here somewhere. Okay, those are integers. Rational numbers are numbers that can be written in the form a over b, where b is not equal to 0 but can implicitly be 1. Some examples are 2 over 1 or 3 over 4. And rational numbers, when converted into decimals, the decimal for 2 over 1 is going to be 2.0, 3 over 4, 0.7, and 5. They either terminate or repeat. But irrational numbers can't be expressed in the form a over b because they don't terminate or repeat. For example, the square root of 2 over 1, that's equal to like approximately 1 point, I think it's like 4142. I really don't feel like writing this out. It's gonna take forever. Literally and figuratively. Yeah, 4142, blah blah blah. I think 1356. You get the point. It's never going to terminate. Try to solve it yourself with long division. You'll see it doesn't. Well, I don't know if most people know how to analyze a square root, but yeah, just try it. It's never going to terminate. Okay. All right. So yeah, basically the range of the y equals cosecant of x is y is less than or equivalent to -1 or greater than or equivalent to 1. Okay? All right. Thanks for tuning in.